This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at surface integrals. To evaluate a surface integral, we let S be a surface with the equation z is equal to g of xy, and let r be its projection onto the xy plane. So we may be dealing with all three variables, x, y, and z, but we're projecting it onto just the xy plane, which means we're going to have double integral. We don't have a triple integral. If g, the partial of g with respect to x, and the partial of g with respect to y are continuous on r, and f is continuous on s, then surface integral of f over s is given with this formula. The integral of f of xyz is equal to the integral, and this is with respect to r, the integration is over r, becomes f of xy g of xy times the square root of 1 plus partial of g with respect to x squared plus partial of g with respect to y squared. So let's take a look at a problem dealing with this. We got x minus 5y plus z, and s is z is equal to 10 minus x, and x is between 0 and 10, and y is between 0 and 10. Well, from our formula, we need two things. We need, actually we need all of this, but let's first focus on this function right here. Now, whenever they give you the z, that's always your g of x, y. That's this right here. So they want us to find f of xy, g of xy, which is going to equal to f of xy, and then g of xy we said was 10 minus x. So we're going to plug the x in for x, the y in for y, and we'll plug in 10 minus x in for the z. Now, the way this always works is whatever you got here, you just can replace in your original function, you replace a z with whatever you have. So this becomes x minus 5y plus z, and again this is our f of xy right here, f of xyz right here, and we're replacing the z with 10 minus x, which is going to give us x minus x drops away, and we got negative 5y plus 10. Okay, that's the first part of our formula. Well, we need a partial respect to x, partial respect to y. So, taking a look at this, partial respect to x is negative 1. Partial respect to y, well, there is no y in there, so that'd be 0. So this right here now becomes, put that in our function, which is negative 5y plus 10, and the square root of 1 plus partial of g with respect to x squared, that was negative 1 squared, plus partial with respect to y squared, like that. Okay, now they tell us that y is going from 0 to 10. So if y is equal to 0, and y is equal to 10. And they're telling us x is going from 0 to 10. So this is x is equal to 0 to x is equal to 10. So dy dx. And that's our setup. Well, 0 squared drops away. Negative 1 squared is 1. 1 plus 1 is 2, so that's square root of 2. I'm going to put that out in front. And then from x equals 0 to x equals 10. And we're integrating the negative 5y plus 10 with respect to y. So that gives us negative 5/2 y squared plus 10y from y is equal to 0 to y is equal to 10. Now we need to plug those values in. Oh, I had to rearrange myself here. Sometimes I sit too long and back starts bothering me. So x equals 0. If you got a few hours, I'll tell you about the other aches and pains I have. Okay, now we'll plug 10 in for the y. So we got negative 5/2 times 10 squared plus 10 times 10 minus, and then I'll put parentheses, has to affect everything that follows it. We'll put 0 in for the y. So I got negative 5/2 times 0 squared plus 10 times 0 dx. Let me see. X equals 0 to x equals 10. 10 squared is 100. Divided by 2 is 50. Times negative 5, negative 250. Negative 5/2 y squared I guess negative 250. Seems a weird number. 50, negative 250, yeah. 10 times 10 is 100. And all those drop away. So that gives us negative 150, and I'll put it out in front. And then we're left with this integral. And that gives us negative 150 square root of 2. Integral of that is x, from x equals 0 to x equals 10, which gives us negative 150 square root of 2, plug in 10 for the x, minus, plug in 0 for the x, which gives us negative 1500 square root of 2. And that's our answer. Let's see, this is surface integrals. Surface integrals. So let me save this. Surface integrals, page 01.pdf. Okay, let's take a look at this problem. Trying to find the surface integral of x minus 4y plus z. S is z is equal to 4. X squared plus y squared is less than or equal to 36. Well, if we set this up, first off, we got x minus 4y, and they tell us what z is. They tell us z is 4, so I can put 4 in for the z. Like that. And this is a circle of radius 6. 5, 6. 1, 2, 3, 4, 5, 6. So it's obviously that it's going from x is equal to negative 6 to x is equal to positive 6. Now if I were to look at this, x squared plus y squared is equal to 36. If I were to solve for y, I take the x squared over, we get 36 minus x squared. We get y is equal to plus or minus square root of 36 minus x squared. So we get y is equal to negative square root of 36 minus x squared, and y is equal to positive square root of 36 minus x squared. Okay. This minus version, that's what's underneath here. This plus version of that is what's up on top. So in setting this up, we're going to go from y is equal to negative square root of 36 minus x squared to y is equal to positive square root of 36 minus x squared. dy dx. Oops, I forgot my square root. Sorry. Okay. Well, remember, your z is your g of xy. So, let me put it over here. Our partial with respect to x is 0. Our partial with respect to y is 0. So this will be the square root of 1 plus the partial with respect to g squared plus the partial with respect to y squared. And then dy dx. Well, 0 squared plus 0 squared, that drops away. Square root of 1 drops away. So we're left with this. Now this one will be easier to switch to polar. So we're going to have r is equal to 0 to, if I do it right, let's try it again. Theta is equal to 0 to theta is equal to 2 pi. Because we're going all the way around the circle. All the way around the circle is 2 pi. And then you have r is equal to 0 to r is equal to our radius. Our radius was 6. Now remember, to switch these, x is equal to r cosine theta, and y is equal to r sine theta. So this x right here becomes r cosine theta minus 4y, which is r sine theta, plus 4, and remember we have to put an extra r when we switch it to polar. Now whenever you have a circle, you may find it easier, not always, you may find it easier a lot of times to switch it over. So then this becomes theta is equal to 0 to theta is equal to 2 pi. R is equal to 0 to r is equal to 6, and I'll multiply the r through, and that gives us r squared cosine theta minus 4r squared sine theta plus 4r dr d theta. Well, let's go ahead and integrate with respect to r. So this becomes 1/3 r to the third cosine theta minus 4/3 r to the third sine theta plus 4 over 2 r squared, from r is equal to 0 to r is equal to 6. Now to save time on this, if I plug in 0 for r, all of this is going to drop away, so I'm not going to worry about that. I'm just going to plug in r is equal to 6. So we get 1/3 times 6 to the third cosine theta minus 4/3 times 6 to the third sine theta plus 4 divided by 2 is 2 times 6 squared d theta. Okay, so that's going to give us let's see, 6 to the third, let me plug in the calculator here, times that, okay, so it gives me 216 over 3 cosine theta minus 6 to the third, okay, and then times 4, 864 over 3 sine theta. 6 squared is 36 times 2 is 72 d theta. Okay, now we're ready to take our... Did I not take any numbers out in front? I guess I haven't. Sometimes I just drop them when I take them out in front. Okay. Well, the integral of cosine is sine, so this becomes 216 over 3 sine theta. The integral of sine is negative cosine, and negative already out in front gives us a positive 864 over 3 cosine theta. And if you got a number, you just put theta on it. And then this is going to go from theta is equal to 0 to theta is equal to 2 pi. Okay, so we'll have 216 over 3 sine of 2 pi plus 864 over 3 cosine of 2 pi plus 72 times 2 pi minus, and then we'll put 0 in. So we've got 216 over 3 sine of 0 plus 864 over 3 cosine of 0 plus 72 times 0. Well, sine of 2 pi is 0, so that drops away. Cosine of 2 pi is 1, so that gives us 864 over 3. 72 times 2, 144 pi. And let's see, minus sine of 0 is 0, so that drops away. Cosine of 0 is 1 times 864 over 3 gives us 864 over 3, and 72 times 0 is 0. So these two cancel, and we're left with 144 pi as our answer. So let me go ahead and save that. Oh. And let's look at our next problem. We got 4xy and s is z is equal to 5 minus x minus y first octant, which means everything's positive and everything starts at 0. So that's going to help us with our setup on this. Now, okay, so we got 5x, 4xy. Well, that's going to remain. We'll come back to those, but this remains as 4xy. Now, remember, this is our g of xy. So that's 5 minus x minus y. Now we need our partial with respect to x, which would be negative 1, and we need our partial with respect to y, which would be negative 1. So from our formula, this is going to be the square root of 1 plus the partial with respect to x squared. So we've got negative 1 squared plus the partial with respect to y squared. So that's negative 1. Okay, now let's talk about our setup. We got z is equal to 5 minus x minus y. Now we're mapping it into our xy, which means z's gone. So we put 0 there. 5 minus x minus y. And if I solve for y, I take negative y over, I get y is equal to 5 minus x. So this is going to go from y is equal to 0 to y is equal to 5 minus x. That was our y's. Now our x's. With the x's, the z's gone and the y's now gone, so we put 0 in for y, and we get 0 is equal to 5 minus x. Take that negative x over, and we get x is equal to 5. So this is going from x equals 0 to x is equal to 5. And then this will be dy dx. Okay. First off, negative 1 squared is 1. So that what's inside of the square root is 1 plus 1 plus 1, which is square root of 3. And we got a 4 here, so I'll put both of those out in front. So I got 4 square root of 3. X is equal to 0 to x is equal to 5, and I'm left with xy here. dy dx. Okay. Well, now we're going to take the integral with respect to y. What did I drop? I dropped my y's, didn't I? Let's try it again. There we go. And we're left with xy dy dx. Okay, so now we're going to integrate with respect to y, which gives us 1 half x y squared from y is equal to 0 to y is equal to 5 minus x dx. So that gives us 4 square root of 3. X is equal to 0 to x is equal to 5. The 1 half I guess I can put out in front, so that would be over 2. And then I got x, and we're plugging these in for y. So I'm going to have 5 minus x squared minus x, and then I'll plug 0 in for y dx. Well, x times 0 is 0, so it drops away. And simplifying this a little bit, we got x times 5 minus x squared gives us 25 minus 10x plus x squared dx, which gives us, let's see, actually I guess I can simplify that, right? 4 divided by 2 is 2. So we've got 2 square root of 3. X is equal to 0 to x is equal to 5. X times 25 is 25x. X times negative 10x is negative 10x squared. X times x squared is x to the third dx. And now we're going to take the integral with respect to x. So that becomes 25 halves x squared minus 10 thirds x to the third and let's see, plus 1/4 x to the fourth from x is equal to 0 to x is equal to 5. Well, now we'll plug the 5 in. So we got 25 halves times 5 squared minus 10 thirds times 5 to the third plus 1/4 times 5 to the fourth. 0 I don't need to plug in because all those would drop away. And I'm getting lazy. Also, I don't want to make a basic math error. I got this weird feeling that I have made a basic math error somewhere, but sometimes you just get that feeling. Minus 10 divided by 3 times 5 to the third plus 1 divided by 4 times 5 to the fourth. 25 halves times 25 minus 10 thirds times 5 to the third plus 1/4 times that times 2. Math enter. So that gives us 625 square root of 3 over 3. Assuming no basic math error. But at least you get the concept of finding the surface integral, even if I did screw up on some basic math. So let me save that. And let's take a look at our next problem. This wants us to find the mass of the surface lamina, S, of density rho. And let me grab a drink here. And you see I give you the formula. We're integrating, we're doing a surface integral, so all that still applies that we've been doing. But instead of a function in there, we have a rho, which is a function of sorts. Okay. So we got our mass, and then our rho is kz ds. Okay, and then S is z is equal to square root of 9 minus x squared minus y squared. And actually I guess that's everything we need. Everything else I wrote down. Well, first off, we can plug this in for the z, make that easier. I'm going to leave these alone for the time being. So I got k times z, and z was the square root of 9 minus x squared minus y squared. Now, remember what we multiplied by now is this, square root of 1 plus all of this. Remember, this is g of xy. So our partial, and that's the same as 9 minus x squared minus y squared to the 1/2 power. So partial with respect to x. Take our 1/2, put it on front. The 9 minus x squared minus y squared remains as is. Lower your power by 1 times the partial derivative of what's inside of parentheses with respect to x, which would give us negative 2x. 2's would cancel, and I'd have negative x over, and I take this to the denominator, and this becomes the square root of 9 minus x squared minus y squared. Now our partial with respect to y. Let's see. We drawing a blank here. Oh, same thing as that, except for it's negative y over square root of 9 minus x squared minus y squared. Well, now we're ready to plug it in our formula. So we're going to have 1 plus partial of g with respect to x squared. So we've got negative x over square root of 9 minus x squared minus y squared squared plus partial with respect to y squared. So 9 minus x squared minus y squared squared. And again, I'm not going to worry about the rest of this. I'm just going to focus on this for the time being. So this is the square root of 9 minus x squared minus y squared. And then this becomes 1. When I square that, that gives me x squared. And I square the bottom part, just gives me 9 minus x squared minus y squared. Square the negative y, and we get y squared. And square this, and the square root cancels. And we got 9 minus x squared minus y squared again. And all this carries down. And I need to get a common denominator. So I can rewrite 1 as 9 minus x squared minus y squared over 9 minus x squared minus y squared. Plus x squared over 9 minus x squared minus y squared. Plus y squared over 9 minus x squared minus y squared. Okay, I'm getting there. 9 minus x squared minus y squared. Now we can, since they got a common denominator, we can add together the top parts. And negative x squared plus x squared cancels. Negative y squared plus y squared cancels, and we've got a 9 up on top. We've got a property from intermediate algebra that says if you got a fraction inside of a square root, we can split it up, put a square root on top, and square root on the bottom. Well, notice something now. This matches that, so they're going to cancel. And square root of 9 is 3, so this gives us 3k. Okay. Well, if we go back to our original problem, wherever it was, we got z equals square root of 9 minus x squared minus y squared. Now remember, z is gone. So once we map it into the x's, z is gone, so we put a 0 there. And we got 9 minus x squared minus y squared inside of a square root. If I square both sides, we get 0 is equal to 9 minus x squared minus y squared. Take the squareds over to the left side, and we get x squared plus y squared is equal to 9. Well, think what this looks like. This is a circle of radius 3. So I can switch this to polar. That's why I didn't bother putting all these in here. And it'd be a lot easier. So theta is equal to 0 to theta is equal to 2 pi. We're going all the way around the circle. And then r is equal to 0 to r is equal to radius, which is 3. And then we got 3k. There's nothing to switch there, but we do need to put an r in. So we get that. And so now we're ready to work this. This is dr d theta. The 3k I can put completely out in front. So mass is equal to 3k. Theta is equal to 0 to theta is equal to 2 pi. And the integral of r gives us 1/2 r squared from r is equal to 0 to r is equal to 3 d theta. Now it doesn't do us any good to plug 0 in for r, because 0 squared is 0 times 1/2 is 0, so just plug 3 in. 3 squared is 9 times 1/2 is 9/2. And I actually can just put that out in front. So 3k times 9/2 from theta is equal to 0 to theta is equal to 2 pi of d theta. Well, that gives us 3 times 9 is 27/2 k. And the integral of this is theta from 0 to 2 pi, which ends up giving us 27/2 k times 2 pi, which gives us m is equal to 54 pi k. And that's our answer. Let me save that. And let's see what we have to look at now. Okay. Now sometimes you have your, and I'll summarize this all at the end, but your surface integrals are in a different form. They're in parametric form. This is where you have r of uv is equal to x of uvi plus y of uv j plus z of uv k. Then this would be the formula you'd use. So let's take a look at this problem. F of xy ds and f of xy is equal to x plus y, and r of uv is equal to 8 cosine ui plus 8 sine u j plus vk, and u is between 0 and pi over 2, and v is between 0 and 4. Okay. Well, first off, let's note something. When you're given the vector form here, this right here is going to be your x of uv. This will be your y of uv, and this will be your z of uv. So So let's take a look at our formula. This says we need to find f of x of uv, y of uv, z of uv. Well, our f of xy is equal to that. And I got z of uv here, but we just got x and y. So, instead of x, I'm going to plug in x of uv, and I'll plug in y of uv, which is going to be f of, let's see, 8 cosine u, and y will be 8 sine of u. So I'll replace the x with 8 cosine of u, and I'll replace the y with 8 sine of u. So that's our function. Now that's all we need right there. Then we've got ds, but ds up here tells us we need the partial with respect to u, partial with respect to v. We're going to find a cross product, the magnitude, and then we're ready to plug it in. Okay, partial, and I'll abbreviate it. Partial with respect to u. Come up here, the derivative of cosine is negative sine, so we're going to have negative 8 sine u I. The derivative of sine is cosine, so that becomes plus 8 cosine u, oops, j. And this doesn't have any u on it, so that becomes 0. We also need a partial with respect to v. Well, this doesn't have any v, so that goes to 0. This doesn't have any v, so that goes to 0. The derivative of v is 1, so that gives us 1k or k. Now we said we need the cross product of these. So it's a determinant. Put I, j, and k across the top. For the partial with respect to u, we have negative 8 sine u, and we have 8 cosine of u, and k is missing, so we put a 0 there. Now for the partial with respect to v, we're missing the I and j, so put 0, 0, and this would be 1. Okay, so we're going to have I, and remember we cross out the row and column it's in, and then we got to determine of what's left. So we got 8 cosine of u, 0, 0, 1, minus j. These alternate. This is plus, this is minus, and this is plus. So minus j, we'll cross out the row and column j's in, and then determine what's left. So we got negative 8 sine u, 0, 0, 1, plus k, and cross out the row and column it's in, and we got negative 8 sine u, 8 cosine u, 0, 0. Okay, we'll cross multiply here. 8 cosine u times 1 is 8 cosine u, so this is 8 cosine u I. And cross multiply here, we got negative 8 sine times 1 is negative 8. With a negative out in front gives us a positive 8 sine u j. And then this times this is 0, this times this is 0, 0 minus 0, 0, so that drops away. Well, now we need the magnitude of this cross product. So we're going to have the square root, and we'll have 8 cosine u squared plus 8 sine u squared, which gives us square root of 64 cosine squared u plus 64 sine squared u. And we can factor the 64 out, and that gives us cosine squared u plus sine squared u, which cosine squared plus sine squared is 1, and then square root of 64 is 8. So that's our magnitude of the cross product of those two partials. Okay, so now we have everything for our formula. So this is going to become, and it doesn't matter what you put, but I'll put the v here. V is equal to 0 to v is equal to 4. and u is equal to 0 to u is equal to pi over 2. And we have our function, which function we said was right here, 8 cosine u plus 8 sine u. So I got 8 cosine u plus 8 sine u times ds, and ds we just found was the something, it was a number. What was it? Oh, it was equal to 8. So times 8. And then du dv. Okay, well, we can take that 8 and put it out in front, and we can even factor an 8 out of these, so that's going to give us 64 out in front. And then v is equal to 0 to v is equal to 4, and u is equal to 0 to u is equal to pi over 2 of cosine u plus sine u du dv. Okay. Take the integral of that. The integral of cosine is sine, so we've got sine u. And the integral of sine is negative cosine, so that's negative cosine u. From u is equal to 0 to u is equal to pi over 2 d theta, or dv, dr. What in the world did I do here? Oh, I switched to r's. Time for me to go to bed. That should be v's. Okay, dv. We'll plug those in now. And we've got 64, and then v is equal to 0 to v is equal to 4. And we're going to have sine of pi over 2 minus cosine of pi over 2 minus, and then we'll plug 0 in for u. So we've got sine of 0 minus cosine of 0 dv. Well, sine of pi over 2 is 1, minus cosine of pi over 2 is 0, minus sine of 0 is 0, minus cosine of 0 is 1 dv. Okay, zeros drop away, and we've got a negative, negative 1. That gives us positive 1, so that gives us 2. We can put that out in front. And we've got 64 times 2 from v is equal to 0 to v is equal to 4 of dv. Which gives us, what's that, 128? Then the integral of that is v, from v is equal to 0 to v is equal to 4. So we've got 128, we'll plug in 4 for v, minus, we'll plug in 0 for v. Which gives us 2, 3, 8, 512. Assuming no basic math error. And that's our answer. And that's how you handle it if you got it in parametric form. So let me go ahead and save that. Okay. And that was that problem, I guess. So let's take a look at this one. ds. And we got f of xyz is equal to x squared plus y squared plus z squared, and s is z is equal to x plus y, and then we got x squared plus y squared is less than or equal to 4. Well, to begin with here, we're mapping this into just x's and y's. But this one has obviously a function involving z. So in order to do our mapping on this, we're going to need to well, first off, let's plug this in here. F of xyz was x squared plus y squared plus z squared. And it's pretty easy to switch this over now because we know what z is. Z is equal to x plus y. We see that right up here. So we can plug that in, and this becomes the integral of x squared plus y squared plus x plus y squared. Which, if I simplify that, we get x squared plus y squared. X plus y to the second power is x squared plus 2xy plus y squared ds. Well, we got x squared plus x squared. That gives us 2x squared. Y squared plus y squared is 2y squared. And 2xy, like that. And I can factor a 2 out in front, so I don't have to worry about it. So bring that 2 out, and we're going to end up with x squared plus y squared plus 2xy ds. Okay, now let's go to work on this. This right here is now going to be or this right here, I guess I should say, our g of xy is going to be our x squared plus y squared. And if I put z squared in there, it really doesn't matter because all we're doing is taking a partial respect to x and partial respect to y. So partial respect to x, that's going to give us wait a minute, what am I doing? I picked the wrong one. Oops. Time for me to go to bed. Z is equal to x plus y. And again, the z is going to just disappear with our notation here because it doesn't exist in that. So partial respect to x is 1, and partial respect to y is 1. Okay, that makes more sense. Okay, so we need those for our formula. So let's come down here, and now we're ready to do our setup. Now keep in mind that what we're dealing with here, x squared plus y squared is less than or equal to 4. That's a circle of radius 2. Which I'm going to switch it to polar form because that'll be easier. Now, first off, let me go ahead and do this part. So we got x squared plus y squared plus 2xy, and then I put my square root of 1 plus a partial with respect to x squared. So we got 1 squared plus partial with respect to y squared. Okay. Well, 1 squared's 1, 1 squared's 1, so all that is square root of 3, so I can put that out in front. So we've got 2 square root of 3. And now let's do our setup, now that we've got that out of the way. Well, we're going all the way around circles, so we're going from theta is equal to 0 to theta is equal to 2 pi. And we start off at r is equal to 0, and we go to r is equal to 2, our radius. Okay. We got x squared plus y squared. Remember, r squared is equal to x squared plus y squared. So I can replace that with r squared. Plus, I factored that 2 out. Oh, I'm fading fast here. Okay, so we pulled that 2 out because I'll have a 2 in common. So that gives us xy. So, remember, x is equal to r cosine theta, and y is equal to r sine theta. Which means that this xy here we can replace with r cosine theta times r sine theta. And switching it to polar, we had to put an extra r there. So dr d theta. Okay, well, let's do a little bit of simplifying. So we've got 2 square root of 3 from theta is equal to 0 to theta is equal to 2 pi. R is equal to 0 to R is equal to 2. Multiply the R through, and we got R to the third. Now here we got R times R, which is R squared, times another R is R to the third. Cosine theta, sine theta. dr d theta. Now we could factor an R to the third out if we wanted to. And if it helps you keep track of everything, you can go ahead and do that. I'm not going to. I'll make sure I have enough room to finish this. So this becomes 1/4 R to the fourth plus 1/4 R to the fourth cosine theta sine theta from R is equal to 0 to R is equal to 2 d theta. Doesn't do me any good to plug 0 in for R because then everything would disappear, so I'll plug 2 in. 2 to the fourth is 16, divided by 4 is 4. And I can take that 4 and put it clear out in front. And then we got theta is equal to 0 to theta is equal to 2 pi of 1 plus cosine theta sine theta d theta. Which gives us 8 square root of 3. And this right here, I can split this into separate integrals if I want, but basically this would be the u substitution. U is equal to sine theta. du is going to equal to cosine theta d theta. So when I take the integral of this, the 1 becomes theta plus, and this is u, and that becomes du, so we add 1 to our power, divide by our new power. This gives us 1/2 sine squared. And I won't show all the steps for that. Hopefully you're used to the u substitution. You've seen it in a couple classes now. From that. Okay. So we got 8 square root of 3, and now I'll plug in these values. So I'll put in 2 pi for theta, plus 1/2 sine squared of 2 pi, minus, and then I'll put 0 in for theta, 0 plus 1/2 sine squared 0. So we've got 8 square root of 3. Now, sine of 2 pi is 0, so that drops away. This is 0, that drops away. Sine of 0 is 0, so that drops away. So we got left with 2 pi. And 8 times 2 pi gives us 16 square root of 3 pi. Guess I could have put the pi out in front, but oh well. Let me save that. Now, these are the instructions on how to evaluate a flux integral. And the book describes what flux is used for in physics, and we're not going to go into that. We're just going to look at how to find it. In physics, you'll go into that in detail of how do you apply this. Let S be an oriented surface given by Z is equal to G of xy, and let R be its projection onto the xy plane. So again, we're projecting it onto the xy plane, so Z is going to disappear. And this is our notation here. We got two different formulas, oriented upward and oriented downward. And you see we're going to find a dot product of F and then the negative partial of G with respect to x, I, minus partial of G with respect to y, j, plus k. Or we just flip the signs if it's oriented downward. So let's take a look at a problem dealing with this. And we're trying to find this integral here, this flux integral. And F of x, y, z is equal to 8zi minus 8j plus yk. And S is going to be x plus y plus z is equal to 5 in our first octant. Well, we come up here. We're going to need to find a dot product of f and then this, so we need to identify g of xy first. If I take this, x plus y plus z is equal to 5, I can solve that for z. So I get z is equal to 5 minus x minus y. And z is the same as our g of xy. So I need the partial of those. So partial with respect to x would be negative 1, and partial with respect to y will be negative 1. Okay, and then this right here is going to equal to, we'll come back to these, f, which is 8zi minus 8j plus yk, dot product of that and what is this anyway? Upward. So it's this first formula here. So we got negative g, or partial respect to x. So that's, I'll learn to speak someday. Negative negative 1 gives us a positive 1, and then I, put an I on it, minus, and then partial respect to y is a negative 1, so negative negative again gives us positive, so that's j, and then plus k. That's always k. That never changes. Okay. Well, let's look at how to set up our limits here. We'll look at y. So we got z is equal to 5 minus x minus y. At this point, z's gone because we mapped it into the xy plane. So z's gone, so we put a 0 for it. 5 minus x minus y. Solve for y, so take negative y over, and we get y is equal to 5 minus x. Now we said first octant, so it starts at 0 and goes to y is equal to 5 minus x. Okay, now for our x's, we got y is equal to 5 minus x. At this point, y is gone, so we'll put 0 in for y, and we got 0 is equal to 5 minus x. Take negative x over, and we get x is equal to 5. So this is going from x equals 0 to x is equal to 5. And this will be our dy dx. Okay, so let's find this integral. The dot product. We multiply what's in front of our eyes. So 8z times 1 is 8z. Multiply what's in front of our j's. Negative 8 times 1 is negative 8. And multiply what's in front of our k's. So y times 1 is y. dy dx. Now we can't have any z's here. But remember, we know what z is. Right up here we said z is equal to 5 minus x minus y. Now I could have plugged it in early on, but I thought it might be easier if I just go ahead and do it the way it is and then plug it in. So we got x is equal to 0 to x is equal to 5. Y is equal to 0 to y is equal to 5 minus x. And so then we're going to have 8 times z, which is 5 minus x minus y, minus 8 plus y. dy dx. Okay, x equals 0 to x equals 5. Y is equal to 0 to y is equal to 5 minus x. 8 times 5 is 40, minus 8 is 32. 8 times negative x is negative 8x. 8 times negative y is negative 8y, plus y is negative 7y. dy dx. Okay, well now we'll take the integral with respect to y. So that gives us 32y minus 8xy minus 7 halves y squared, from y is equal to 0 to y is equal to 5 minus x dx. And if I plug 0 in for y, it won't go anywhere. 32 times 0 is 0. 8x times 0 is 0. 0 squared is 0 times 7 halves is 0. So all I need to worry about is a 5 minus x. So we got 32 times 5 minus x minus 8x times 5 minus x minus 7 halves times 5 minus x squared dx. Okay. So that's going to give us 32 times 5 is 160. I think so. 32 times negative x is negative 32x. Negative 8x times 5 is negative 40x. Negative 8x times negative x is positive 8x squared. Minus 7 halves times 5 minus x squared is 25 minus 10x plus x squared dx. Okay, so we got 160. Negative 32 minus 40 is negative 72x plus 8x squared. 25 times 7 is 175, so negative 175 over 2. Negative times negative is positive. 70 over 2 is 35x. Negative 7 halves times x squared is negative 7 halves x squared dx. Okay, let me write that down, so I'm out of room. Where's a pen? There we go. X is equal to 0 to x is equal to 5 of 160 minus 72x plus 8x squared minus 175 over 2 plus 35x minus 7 halves x squared dx. Okay. So let me save that page. This will be number 7 continued, I guess. Continued. So we got the integral x equals 0 to x equals 5 of 160 minus 72x plus 8x squared minus 175 over 2 plus 35x minus 7 halves x squared dx. Okay. So we got x is equal to 0 to x is equal to 5. And 8x squared, which is 16x squared, minus 7 halves, or 16 over 2x squared, minus 7 halves x squared gives us 9 halves x squared. 9 halves x squared. Yeah, 9 halves x squared. Negative 72x plus 35x, that gives us 37, negative 37x. 160, that's 320 over 2. 320 minus 175 is 145 over 2. Is that negative or positive? Dx. Okay, now we're ready to take the integral with respect to x. So add 1 new power, divide by new power. So that gives us 9 halves times 1/3 x to the third minus 37 halves x squared plus 145 over 2x. X equals 0 to x equals 5. Now again, it doesn't do us any good to plug 0 in for x because all of those would drop away. And I'll do a little bit of simplifying as I'm plugging a number in. 9 divided by 3 is 3, so that gives us 3 halves times 5 to the third minus 37 over 2 times 5 squared plus 145 over 2 times 5. And where's my calculator? I'm going to do this the easy way. 3 divided by 2 times 125 minus 37 divided by 2 times 25 plus 145 divided by 2 times 5. Math inner 175 over 2. And that'd be your answer. So let me go ahead and save that. Then we'll talk about a summary of the different forms. Key part as you're going on in math is being able to read the formula. And you know the basic techniques, but then take the formula and figure out how to write it. Based upon everything you've been shown, you should be able to now go through these formulas and find whatever form you're talking about. Now, if it's asking you to find the surface integrals, and it gives you a z, your s is z equals something, then use this formula. So we've got ds, which is the square root of 1 plus partial of g with respect to x squared plus partial of g with respect to y squared. And then you see we got our f of xy, g of xy. We looked at that. You plug whatever your z equals in for the z to get it to disappear. And then times that square root. Now if you find a flux, that's what this last one is, and this is just one of them. Remember there's two versions of that. Then use this formula. Well, if you got surface integrals in this parametric form, where you got r equals, r of uv equals, well, we'll be able to find, we'll have to find our partial with respect to u, partial with respect to v, find the cross product, find the magnitude, we've seen this, and then use that in an appropriate place. You see down here the actual surface integral. We got f of x of uv, y of uv, z of uv times ds, which is all of this. And if you're finding the flux, well, you can find the dot product of f and n is this over here. So again, you should be able to look at these and based upon the examples we've seen, be able to solve any of these forms now. So let me go ahead and save this.